Yes, dear students, uh, new topic. Though I suspect this has been deleted, but important to learn. It will be used at many places in physics. While learning physics, you will need it at many places. So don't go to that. Actually, you have to learn subject. You have to go higher. Here it is the electric field due to charge conducting spherical shell. Shell, you understand, hollow sphere of thin skin. Means this outer radius, inner radius supposed to be same. You know, if we give charge to this conductor, it gets spread over this whole surface uniformly. Let surface charge density be sigma coulomb per meter square. What is this? Charge convey, so total charge Q 4 pi r square into sigma. Sigma is here surface charge density. What does it mean? Surface charge density means charge per unit area. And you know, if r is the radius of a sphere, then the surface area is 4 pi r square. And hence total charge Q sigma into 4 pi r square. This charge gets spread over the whole surface. We can find out electric field at any point P outside here. So for this we apply Gauss theorem, and you know, to apply Gauss theorem we need a Gaussian surface, closed Gaussian surface. Here the closed Gaussian surface, closed Gaussian surface, Gaussian surface is a sphere of radius capital small r. Now, if charge is positive, this topic is very interesting. In fact, if charge is on the sphere and this is closed Gaussian surface, then whole charge inside will be Q. Now, applying Gauss theorem to this surface, integration E dot ds is equal to total charge Q upon epsilon 0, or Q given Q in place of sigma into 4 pi r square is equal to epsilon 0. Nothing else. I have here put the value of Q. At every point of cell, vector E and vector ds. ds vector means area element, surface area element, always on sphere are parallel. Because if charge Q positive, electric field positive outside and area outside. So this equation can be written as integration S E ds Q upon epsilon 0 is equal to sigma into 4 pi r square upon epsilon 0. Sigma surface charge density. Now, at every point of this sphere, magnitude of electric field same, so we can write E integration ds for closed surface equal to Q upon epsilon 0 equal to sigma into 4 pi r square upon 0. If I take these two here, so into integration ds is 4 pi small r square. Why? Because Gaussian surface has radius small r. 4 pi r square is the area of sphere. This is not circle here, it is sphere. sphere here is equal to Q upon A equal to sigma into 4 pi R square upon. Now taking these two, we get E equal to 1 upon 4 pi epsilon 0 Q upon R square. 4 pi epsilon into R square. Do you remember we have learned such a formula? Now we have learned a formula of this type very early. That is the field due to point charge to a distance R. Therefore, so 4 point P, which is outside the cell, it appears the electric field of a point charge at center of cell. This is very interesting. Like E equal to 1 upon point Q upon R square. The charge is distributed here. Distance R is this. So this will appear to be as if the whole charge is at center. Similarly, or you can write this equation as I direct as equation 1. Now if I take these two, so then we get here E equal to 4 pi sigma R square upon epsilon 0 into small r square. This the same thing. If we put the value of sigma equal to Q upon 4 pi R square. Here sigma equal to Q upon 4 pi R square. So we will get this result. So 4 point P outside, the electric field appears as if whole charge at center. Now, if point P is at surface, this is very important here. That is small r is equal to capital R. Then field at surface 1 upon 4 pi epsilon 0 Q upon R square. Again, while charge at surface, but this is formula, this is the distance. Now the whole charge appears at center. So for a point outside the cell or for a point on surface, electric field appears as if the field of a point charge placed at center. This is very important. Now, or if I write this formula in terms of charge density, है भाई, तो वो क्या हो जाएगा? E equal to sigma upon epsilon 0. This expression may be used to tell the electric field at any point of surface of conductor, may be small or big. If we, at any point we know surface charge density, then at the surface of conductor is then E equal to sigma upon epsilon 0. Now if we take point P here inside, if point P is inside the charge cell, then ना भाई तब क्या लगेगा आपको? Then if we think Gaussian surface here, that this Gaussian surface has no charge inside, and hence if we find P is inside the cell, then Gaussian surface does not include any charge, and hence E into 4 pi r square equal to 0, or E equal to, at every point inside, whether it is here or here, wherever the point is there, the electric field inside the charge cell is 0. But dear student, make a note here. Not only the conducting cell, hollow conductor cell. If we have a solid sphere of conductor, if we have a conductor in any shape, whether a solid sphere or maybe a slab or cube or any irregular shape, if we have a conductor or any shape and has if we have a conductor, I should say a charge conductor, simple ho jayega, charge conductor in any shape, then electric field inside it is 0. किसी भी चार्ज कंडक्टर अंदर फील्ड 0, whatsoever say. And if you know the surface charge density at any point of a conductor, then you can tell the field equal to sigma upon epsilon 0. The field will point radially outward, normal to surface if charge is positive, and inward if it is negative. I think this is clear. Now, if we plot a graph here between electric field and distance from charge cell, R, the distance from center, and E, R equal to ये capital R हो गया, and then so on. तो जब तक till the point P inside field is 0, and when we come to surface, electric become maximum, and then decreases. This value is E value here is 1 upon 4 pi epsilon 0 Q by R square. Field inside 0. ये ग्राफ शो करता है. This indicates that field inside charge cell is 0. Okay, bhai. So this is an application of Gauss theorem. One more application is there, which is also important for competition purpose of view. I will take that in next video. Thank you.